Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem count number of homogeneous substrings. Alright, so this is a medium level question and has been asked by Virtue Financials, and the topic tags of this question are math and string. Yes, so let us go through the question now. So given a string S, written the number of homogeneous substrings of S. Since the answer may be too large, return it modulo 10 power 9 plus 7. Alright, so we'll be understanding what is a homogeneous substring now. So a string is homogeneous if all the characters of the string are the same. Alright, so a particular string that you're considering, either maybe it might be a substring or a string that you're considering, it is homogeneous if all the characters of the string are the same. Alright, so a substring is a contiguous sequence of characters within a string. That's very evident. So these are sample examples. We'll see that in brief, and the constraints are S length of the string goes up to 10 power 5, and S consists of only lowercase letters. Alright, only lowercase letters. So I've implemented two solutions. Both are working perfectly fine. One is taking us extra space of O of n. The other is not taking any extra space, just O of 1. And in both of the cases, the time complexity is O of n. So I'll be showing both the codes in the in this particular video. All right. And let us put this fact forward. This question is pretty simple if you identify that small, observation. All right. There is a pretty small observation that need to be, identified, and if you identify that, this is very easy question. There is no doubt about that. All right, so going through the examples, this is the example one. All right, so what is the string that has been given to us? A B B C C C A A. All right, so this is the string that has been given, and the output is 13. Why is it so? Let us see that right now. So I'll just erase this part. Yeah, okay. So they are asking to return the number of homogeneous substrings. All right, number of homogeneous substrings. It is to be noted that a string or a substring of length 1 is indeed homogeneous, right? Because it's very evident. Homogeneous in the sense, according to them, all the characters are same. Now if I have a substring of length 1, that means there is only one character. Alright, so there is nothing to be compared. So definitely one character substrings are always homogeneous. Alright, there is no doubt about it. Now only concern is, so in that case, number of substrings would be, if I'm considering only a substring of length 1, so in that case, this one going to contribute one homogeneous substring. This is also going to contribute 1, 1, 1, 1, 1, 1, 1. So in total have got like one length substrings as 3 plus 3 plus 2, 8. All right, so this is one length, okay, this is one length. So length of one like one length substrings. All right, now let us consider two length of 2. Okay, so in that case, so this particular substring can be homogeneous because B and B, all the characters are same. So in that case, this is one. And coming to this particular double C, so this can also constitute one homogeneous substring because C and C both are same. Similarly here as well, both are same. So one C and C CC, this particular substring can be homogeneous because all the characters are same. Now coming to here as well, this AA can also be homogeneous because all the characters here are same. So totally how many are there? Two length substrings. There are four 2 length that are homogeneous. All right, 4 2 length that are homogeneous. Okay, now we are done with one length, we are done with 2 length. Now 3 length of 3. Okay, what is this? Only this is there, right? Only this is there. All the characters in this particular substring are same, and this is of 3 length. Is there any other 3 length substring that's possible? No. So there is only one, that is 3 length. Okay, 3 length. So in total, how many substrings are there? 8 plus 4 plus 1, that is equal to 13. So that is the reason 13 is the answer. Getting my point? So this is very evident, very simple. Just that they're asking us to find the number of substrings in which all the characters of that particular substrings are same. Alright. So individually, every character is a substring. Individually, every character is a substring. So all those will be constituted to one length substrings. And now considering 2 length substrings, find those substrings that have 2 characters adjacent to each other, because we are looking out for substrings, not subsequences. For substrings, all the characters must be that we are considering must be contiguous. All right, it's not like random, it must be continuous, and then only you can consider it as a substring. So here we have found out that 2 length substrings there are 4, and even 3 length is 1. So just add them, all of them, 1 length, 2 length, 3 length, 11, so it's 13. All right, so I hope you people understood. So I'll just erase this part. Pretty simple. We'll just go through the examples and then figure out the approach. And same is the case here, xy. So xy, in the sense there are only two characters, so each would be contributing to one length substrings. So this is individually one length homogeneous substring, this is individually a one length homogeneous substring, so totally 2 is the answer. All right, so that is the reason 2 is the output. And coming to this is a good example. This would actually clear your doubts if there are any. So the substring that is given is z, 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 z. Okay, there are 5 sets. All right, now one length. Okay, one length, how many can constitute? This can constitute 1, this 1, 1, 1, 1, so totally 5. Okay, 5 one length, 5 one length. Okay, 5 one length, isn't it? Because all the individual z's can be a contiguous, can be a homogeneous substring of length 1. Okay, now length 1 is done. Now coming to length 2. So this can be an homogeneous substring, this can be an homogeneous substring, this can be an homogeneous substring, this can be a homogeneous substring. We are only talking about length 2, not length 3, 4 or 5, only length 2. All right, so how many are there? 4. All right, so in this case 4 2 length, 4 2 length. Okay, now coming to length 3. So 2 length is done. Now coming to length 3. So this would be one substring, this would be one substring, and this would be one substring, isn't it? So all these 3 substrings are homogeneous because all the characters in that particular substring are same. So this is 3 length substrings. Okay, 3 length. And now coming to 4 length. Okay, so 4 length. So what is 4 length? So from here to here there is a 4 length substring, and from here to here there is a 4 length substring. That's it. There are no other 4 length substrings. So how many are there? 2. So 2 4 length substrings. 4 length substrings. All right, this is also done. Now 5 length. So what is 5 length? Consider the whole substring. Okay, consider whole the string as the substring. So in that case all the characters are same, right? So this is again an homogeneous stuff. So there is only one 5 length. Okay, 5 length. Is 6 length possible? No, that's impossible, next to impossible, because only string length is 5, and how can you find out a substring of length 6? That's not possible. So what is the sum of all this? 5 plus 4 plus 3 plus 2 plus 1, that is 15. All right, so that is the reason answer is 15. I hope you people understood what are they actually asking us to give. So this is the understanding of the question through the examples. Now let us figure out the approach. Pretty easy approach, pretty easy. From this question itself we can actually from the test cases itself we can actually figure out the pattern that's actually being there here. So there are 2 cases. Okay, 2 cases. First case, okay, this is the problem, I would say problem. So there are 2 cases of this problem. Okay, 2 cases of this problem. If the present index element, like let us assume I'm on s of I, all right, and I not equal to 0. Okay, I not equal to 0. If s of I actually equal to s of I minus 1, okay, this is the first case. In second case is s of I not equal to s of I minus 1. So here also I not equal to 0. All right, both of these are the 2 cases. Only these 2 cases are there in this particular question. There's no other case. If s of I equal to s of I minus 1, then I can make this s of I a part of all the substrings that are possible for s of I minus 1, isn't it? So let us assume for s of I minus 1 there are there are x number of possibilities of homogeneous substrings. Okay, homogeneous substrings. All right, let us assume there are x number of homogeneous substrings for s of I minus 1. Now for all these x I can add s of I, isn't it? Now for all these x number of possibilities I can add s of I, because in all these x number of possibilities I could find s of I minus 1. Now if I have s of I minus 1, and if I say s of I is actually equal to s of I minus 1, and remember what are we trying to do? We are trying to find the homogeneous substrings, and for that if a particular character is same as the before character, then I can happily mix those both, isn't it? So what are all the x number of possibilities I have? I can all those x number of possibilities I can include s of I minus 1. All right, I can include s of I minus 1. That's it. That is what I'm doing. So for this particular s of I, the number of substrings that are homogeneous that are possible is 1 plus x. All right, 1 plus x. Why 1 plus x? 1 individually it's going to contribute, isn't it? S of I individually is an homogeneous substring, and for all the x possibilities possibilities, we can include S of I. So that's the reason X would be also the number of possibilities of homogeneous substrings for including S of I. Alright, including that are substrings including S of I as the last element, including S of I as the last element. So if S of I minus 1 is in number of homogeneous substrings that are possible including S of I minus 1 as the last substring are X, then I can put S of I to all those X number of possibilities, and all of them would result in homogeneous because S of I equal to S of I minus 1. But what if S of I is not equal to S of I minus 1? There is no other possibility, only one possibility, only one possibility, like only this individually S of I will be an homogeneous. Okay, there is no other possibility for here. So in that case, S of I number of possibilities including S of I, like substrings that have S of I is and homogeneous are only one, that is S of I itself. Only S of I would be substring of length 1 that is homogeneous. There is no other possibility. All right, so I hope you people understood. So let us dry run this with this particular case for the very first example case. All right, so the example that's been given to us is A B B triple C A A. Okay, now let us assume we are standing on this particular point. All right, we are standing on the particular point. Initially the number of substring possible that are homogeneous is 1, because A will only constitute only one, alright, only one character. So leave about the right side, only focus on the particular index. So now the answer is 1. Okay, now the answer is 1. Coming to this particular thing, alright, now let us erase this. Coming to this particular thing, and now B is not equal to A. B is not equal to A. So number of substring that are homogeneous possible for A are 1. Alright, so we cannot include B to that one character because one possibility, because B is not equal to A. So now this individually will constitute 1 for sure. So now answer is equal to 2, because 1 plus 1. So I have done a plus 1. So plus 1, because B is individually an homogeneous substring. Alright, now coming to this particular thing. Now because B is actually equal to B, so in this case, how many were the possibilities of B? So let us even list out the possibilities on the above part itself. 1 1. So B individually will be an homogeneous substring. Now I can include this particular B with this particular B. Alright, so in that case, there is one substring like B and B, this is homogeneous, and individually this B can be an homogeneous substring. So B, so how many possibilities are there? 2 possibilities are there. So in that case, the answer here, the possibilities here are 2. Let me erase this part. So this is B and this is 2, and my answer, alright, now my answer is plus 2, so answer would be equal to 4. Now coming to this particular point. So coming to this particular point, again C is not equal to B, right? C is not equal to B. So C individually can be an homogeneous substring. So here the number of contributions are 1. So in this case, my answer would be equal to 5 plus 1. All right, so now let us come to this particular point. Here again, C is actually equal to C. So how many possibilities are there for the previous C? There is only one possibility. So now add this particular C to this particular possibility, and individually it can constitute 1. So there are 2 substrings that are possible. So answer, okay, plus 2, answer is equal to 7 now. And we'll even erase this part. Now coming to this particular point. Okay, now C, to the previous of that C, there are 2 substrings possible. All right, so we can include this particular C in those 2, and individually C can constitute 1. So totally 3 possibilities are there. All right, so let us even erase this particular thing. So there are 3 possibilities here, and here the answer would be plus 3, so answer equal to 10. All right, now coming to this particular point again. Okay, coming to this particular point, again A is not equal to C, so individually it will only constitute 1 substring, and that will only be the homogeneous part including A. There's nothing others homogeneous substring. So here in this case, the contribution will only be 1. All right, so I'll just erase this part, and here plus 1. Okay, plus 1, so that is answer equal to 11. And now finally we are on this particular point A. So previous A, there is one possibility of homogeneous substring, so we can add this particular A to that particular homogeneous substring. So the number of possibilities here are 2. So what are this? A can be a possibility, and A alone would be another homogeneous substring. So totally of 2. So in this case, the answer would be Answer would be 13. Okay, because plus 2. So this is the final answer, and yes, it matches. All right, I hope you people understood. Pretty easy question. So this is the dry run of the first example. Similarly, you can even do the dry run for the third example as well. Similarly, you can just follow the same pattern. If you people have understood the question, then it's pretty straightforward, pretty evident. Nothing to think out of the box or something. Very easy solution for this particular question. So let us go through the solution now. So this is the DP method. So because they have clearly indicated that the values can go up more than 10 power 9 and out of the integer range, so it's better to make use of int mod, that is 1e9 plus 7. And now this is the space usage method. Okay, we are using a DP method. I'm taking a DP vector and using it. In space optimized, we will not be using it. Let us first go through DP method and analyze these things. Okay, first I've taken DP of s dot length of n comma 1, because every individual character will be constituting to a one length homogeneous substring. That is the reason every index will be having 1. So for int I equal to 1, I less than s dot length I plus plus. If s of I is actually equal to s of I minus 1, then add all the DP of I minus 1 possibilities. Okay, if there are x number of homogeneous substrings possible for I minus 1, then add all those to the DP of I. All right, that is the very pretty simple observation that we have done, and that's what we are doing. And finally, accumulate in the sense, add up all the elements from DP dot begin to DP dot end, add all the elements of the DP vector. And 0 LL is what we are considering, because it may go up more than integer range. That's the reason we are considering 0 LL. And return some ampersand mod. So because we want it to be in the integer region, integer is a function, so we want it in the integer range, so that's the reason some ampersand mod. I hope you people understood. Generally we use only 0, in which if the sum is int, okay, if int is sum is int, then we'll be using 0, but here the sum is long, so that's the reason we use 0 LL. All right, and now this is DP method. If you clearly observe, all right, we are only depending upon the previous value, isn't it? For DP of I, I'm not depending upon DP of I minus 2 or I minus 3 or I minus 4 or so anything. I'm just depending on the previous value. That's DP of I minus 1. So same thing I'm using here. So instead of storing a DP vector for that particular reason, why don't I just use the previous values and current values? All right, very thoughtful observation, right? Instead of using all the length vector, why should we actually use it if we are only depending upon the previous value? That's the reason I've used previous, like in previous equal to 1, and answer would be initially previous. And now for every s dot length, for every particular index, my current would be 1. And if particularly s of I is actually equal to s of I minus 1, then I'll be adding all the previous values elements to my current value. All right, and now my previous would be current, because for the next iteration, for the next element, my for the next element, the previous of that would be my current value. So previous is equal to current, and I'm adding the answer plus equal to current. So if s of I equal to s of I minus 1, then I'll be adding previous to the current. If it is not equal, then I'll be just adding 1 to it, because int cur equal to 1. We are initializing cur with 1 for every element, because every element will individually constitute a one length homogeneous substring. So int cur would be 1, and for every iteration we are updating it, like for every element we are updating if its previous value is the same, if the previous element is actually same as the s of I. So s of I equal to s of minus 1, then we are updating current by adding the previous values to it. If not, we are just adding answer plus equal to current. And finally ampersand mod. All right, so this is the space optimized. So this is a very good method actually. So pretty simple observation, pretty simple logic. I hope you people actually understood the problem. So just these two things, s of I equal to s of I minus 1, if not, s of I not equal to s of I minus 1. That's it. So first example dry running would have cleared all your doubts, and this I'm leaving is that it as a task to you. Very simple. Follow the same thing that we have done, and you'll be happily getting the answer as 15. Okay, so let us even submit the code for your reference, and it will definitely work because I checked already. Yes, all right. So and for your reference, so for your just closing this, I don't know how to close this particular thing. Okay, so for your reference, codes in C++, Java and Python have been attested in the description. Please go through them if in case you're not able to code on your own. So thank you for watching guys, stay tuned.